This is Dr. Thimm talking on carboxylic acids. Um, the introduction part of this carboxylic acid is the carboxylic acid contains a carbonyl group and a hydroxyl group on the same carbon. Carboxyl group is usually written as a COOH. Aliphatic acids have an alkyl group bonded to COOH functional group. Aromatic acids have an aryl group. Fatty acids are long chain aliphatic acids. Common names: many aliphatic acids have historical names. Positions of substituents on the chain are labeled with Greek letters like alpha, beta, gamma, delta, epsilon, etc. For example, this is alpha chloropropionic acid, a gamma amino butyric acid. So the IUPAC names. So remove the letter E from the corresponding alkane or alkene name and add OIC acid. The carbon of the carboxyl group is number 1 always. For example, 2-chlorobutanoic acid, trans 3-phenyl 2-propanoic acid, which is nothing but the cinnamic acid. Naming of the cyclic acids: cycloalkanes bonded to carboxylic group are named as cycloalkane carboxylic acids. Aromatic acids are named as benzoic acids. Dicarboxylic acids: aliphatic diacids are usually called by their common names to be memorized. For IUPAC name, number the chain from the end closest to a substituent. Two carboxyl groups on a benzene ring indicate a phthalic acid. So the structure of the carboxyl group: carbon is sp2 hybridized. Bond angles are close to 120 degrees. The OH eclipsed with carbonyl group to get overlap of pi orbital with orbital of lone pair of oxygen on lone pair of electrons on the oxygen atom. Boiling points: higher boiling points than similar alcohols due to dimerization. Here you can see the hydrogen bonds. Um, so the two carboxylic acids are joined together through hydrogen bonds, for example acetic acid. Melting points: aliphatic acids with more than 8 carbons are solids at room temperature. Double bonds, especially the cis isomer, um, the lower the melting point. So the stearic acid, oleic acid, linoleic acid. So far as the solubility is concerned, water solubility decreases with the length of the carbon chain. Up to 4 carbons, acid is miscible in water, more soluble in alcohol, also soluble in relatively non-polar solvents like chloroform because it dissolves as a dimer. So acidity of the carboxylic groups, you can see here on alcohol in the presence of water it becomes an alkoxide ion, and this carboxylic acid in the presence of a weak base like water, it's the carboxylate anions that get stabilized by resonance, which is illustrated in terms of their energy diagram. So actually this carboxylate anion gets stabilized by resonance. So substituent effects on acidity, which is very clearly illustrated. So the trichloroacetic acid is much more stronger acid than acetic acid. Salts of carboxylic acids: sodium hydroxide removes a proton to form the salt. Adding a strong acid like HCl regenerates the carboxylic acid, which is shown here. Naming acid salts: name the cation, then name the anion by replacing IC acid with ATE. Properties of acid salts: usually solids with no odor. Carboxylate salts of sodium ions, potassium ions, and lithium ions and ammonium ions are soluble in water. Soap is the soluble sodium salt of a long chain fatty acid. Salts can be formed by the reaction of an acid with sodium bicarbonate, releasing carbon dioxide. And purification of the acid can be performed by solvent extraction, as it is illustrated there. Some important acids: acetic acid is in vinegar and other foods used industrially as solvent. catalyst and reagent for synthesis, fatty acids from fats and oils, benzoic acid in drugs, preservatives, adipic acid used to make nylon 66, phthalic acid used to make polyesters. The infrared spectroscopy will help us to determine the presence of the carbonyl group as well as the hydroxyl group. The NMR spectroscopy also helps us to determine the, the proton of the carboxylic group. UV spectroscopy, saturated carboxylic acids absorb very weakly around 200 to 215 nanometers. If carbon-carbon double bond is conjugated with carbon-carbon-oxygen bond, molar absorptivity is in the range of 10,000 to 10,000 at 200 nanometers. An additional conjugated double bond increases the absorption wavelength to 250. And this is the mass spectroscopy. As you all know, the mass spectroscopy is a very powerful tool to determine the molecular mass of an organic compound. This is the synthesis review. We can prepare acids by various methods. The first method could be oxidation of primary alcohols and aldehydes with the chromic acid. Chromic acid is an oxidizing agent. Cleavage of an alkene with the hot potassium permanganate produces a carboxylic acid if there is a hydrogen on the double bonded carbon. Cleavage of an alkyne with ozone, which is so powerful um, oxidizing agent, or hot permanganate. Alkyl benzene oxidized to benzoic acid by hot potassium permanganate or hot chromic acid. Grignard synthesis. Grignard reagent has a general formula RMgX. So R is an alkyl group and aryl group. Magnesium X is a halide. Grignard reagent plus there's carbon dioxide yields a carboxylate salt. Carbon dioxide, here we are going to add dry ice to add carbon dioxide. This is an example of preparing a carboxylic acid starting from a Grignard reagent. This is another method, hydrolysis of nitriles. Basic or acidic hydrolysis of a nitrile produces a carboxylic acid, which we have converted bromocyclohexane to hexanoic acid. Acid derivatives, the group bonded to the acyl carbon determines the class of compound. OH, carboxylic acid, Cl acid chlorides, OR dash esters, NH2 amides. These interconvert via nucleophilic acyl substitution. And this is the Fischer esterification. It involves a reaction between acid and an alcohol, which gives an ester and water molecule. Acid catalyzed for weak nucleophile. All steps are reversible. So reaction reaches equilibrium.